Chemical reactions in aqueous solutions. The last type of reaction in aqueous solution is oxidation reduction, which is the electron transfer from one reactant to the other. One example of a redox reaction is magnesium plus water results in magnesium hydroxide and hydrogen. In this case, magnesium is oxidized and hydrogen is reduced. And now I'll get to the what and why. When a substance loses electrons, it becomes oxidized, and when it gains electrons, it goes through reduction. And the way to memorize this is that Leo says GER, and this stands for lose electrons oxidized, and GER is gain electrons reduction. One other way you can memorize this is oil rig, which is an acronym for oxidation is loss, reduction is gain. Oxidation numbers are defined as the charge that an atom would have if the compound was composed of ions, and they are used to keep track of electron transfers to see which elements are oxidized and which are reduced in a certain equation. When assigning oxidation numbers, there are 5 basic rules. The first rule is that free elements have an oxidation number of 0. So copper or Cl2 both by themselves have an oxidation number of 0. The second rule is that monoatomic ions have oxidation numbers equal to its charge. So Ca2+ has a charge of 2+, so its oxidation number is +2. And Cl- has a charge of -1, so its oxidation number is -1. The third rule is that the sum of the oxidation states of all atoms in a neutral molecule or formula unit is equal to 0. So H2O, which is a neutral molecule, has an oxidation state of 0. And the sum of oxidation states of all atoms in an ion is equal to the charge of an ion. So an ion like NO3- has an oxidation number of -1. The fourth rule is that oxidation numbers are positive for metals and their compounds. And group 1A metals have a +1 oxidation state. So sodium, which is a group 1A metal, has a +1 oxidation state in sodium chloride. And group 2A metals have a +2 oxidation state. So calcium and calcium fluoride has a +2 oxidation state. The final of the basic oxidation number rules is that in their compounds, nonmetals are assigned oxidation states according to this table. The ones you might want to focus on are that fluoride has a -1 oxidation state, hydrogen has a +1 oxidation state, and oxygen has a -2 oxidation state. Going back to the original equation, the first thing you're going to want to do is assign oxidation numbers. Magnesium is a free element, so it has an oxidation number of 0. And H2O is a neutral molecule, so the sum of all oxidation numbers equals 0. And according to the chart, hydrogen is a +1 oxidation number, and oxygen has a -2 oxidation number. Then, in magnesium hydroxide, magnesium has an oxidation number of +2 because it is a group 2A metal. And then oxygen and hydrogen follow the oxidation numbers from the chart, so oxygen has a -2 oxidation number and hydrogen has a +1 oxidation number. Then hydrogen by itself is a free element, so it has an oxidation number of 0. With the oxidation numbers, you can now see that magnesium was oxidized because it went from 0 to +2. And with a +2, it means it lost electrons. So Leo, lost electrons is oxidation. You can also see that hydrogen went through reduction because hydrogen goes from +1 to 0. And because that number is decreasing, it means that it has gained an electron. And so gain electron means reduction, as you know from GER and Leo says GER, or rig and oil rig. In review of redox, here is a visual, and so you can see that compound A is losing electrons to compound B, and compound B is gaining electrons from compound A. There are 4 classic chemical reactions: precipitation, acid-base, combustion, and gas forming. I already talked about precipitation and acid-base, I'm not going to talk about those again, and gas forming I don't need to talk about, so the only one left to talk about is combustion. Combustion emits heat and is when a substance combines with oxygen to form one or more oxygen-containing compounds. The general formula for combustion is hydrocarbon plus oxygen results in CO2 and H2O. One reactant is always oxygen, and the products always include carbon dioxide and water. One specific example is methane plus oxygen results in carbon dioxide and water.
Created using Powtoon.